C# is an object-oriented programming, and that means that everything in C# is treated as an object. You've been working a lot already with the console object. The console object has properties that you can change, like its background color, foreground color, and we can set those to things. Console object also has methods associated with it. So every time we call this line, we're clearing the console. There's a verb here, so something that we do, as opposed to properties, which are things about the console. Even when we declare new variables, say we declare a new integer variable called myInt, that myInt is actually an object that has some baked in properties and methods associated with it already. So in this demonstration, we are going to create our own objects, and in an object-oriented programming language, we need to distinguish between an object and a class. So a class is a blueprint that tells us how to create an object. So if I showed you a blueprint of a building, you would be able to create multiple buildings from that blueprint. You could build the same house on multiple lots because you have that one single blueprint. Each house would be an object. You might have 3 houses based on that blueprint that were all based on the same class. So one class can have many objects. Those two words are not interchangeable. So whenever we are creating user-defined classes, we actually want to code our user-defined class before coding inside of the method that contains, inside of the class that contains our main method. So right now, all the main method has is clearing the console and waiting for a key press. So when I run that, that's the extent of what I'm getting. And to create a user-defined class, you want to right-click in your project, not your solution, but down here in your project, and click on Add and Class. There's the keyboard shortcut for it. And when you do that, it will prompt you for a name. Just make sure that you keep this .cs extension so that the compiler knows it's a C# file you're working with. And here's where you would type in the name of your class. I have already done this and created a new class called building.cs. And I already created one because I wanted to put these comments in here so I wouldn't have to type them during the demo. By the way, to change that font size, I'm just holding down the control key on my keyboard, and if I do mouse wheel up, that makes the text larger. Mouse wheel down makes the text smaller, just to make this easier for you to see. So the first thing inside of our user-defined classes, we want to put our local private variables. And what do I mean by that? I mean these are the variables that are going to change for each object, and we want to give those private access. And that will make more sense later. But to declare a new variable as private, we start out with the reserved C# word private and then the data type. Everything after the word private is just like declaring any other variable. So I want to declare a string variable called name. That's going to be the name of my building. I want to create a integer variable called square feet because each building is going to have a different square feet value, and I'll show that as an integer. And then let's finish it off with a double variable for the cost of the building, the construction cost of the building. Okay, and notice that these 3 variables did not occur or were not declared inside of a method. This is our class. Here's the opening curly brace for our class, and there's no method here. These are class level variables. Okay, now a constructor. We're going to code a few constructors, and a constructor is the method that we are going to call from our building app method that contains our building app class, that contains our main method, that can create an object based on this class. And these are very simple methods. All of the methods in our user-defined class we want to declare as public. So local private variables are going to have private access, whereas all of our methods are going to have public access. So I start with this reserved public keyword, and then we don't need a return type for our constructor. methods. And so the name of this default constructor method should match the name of our class. Okay, so this is a method which shares the same name as the class. And then all we need here is opening and closing curly brace. Probably the simplest method you'll create, and actually we're done here. So this is a default constructor that's just going to create an object based on this class. Now, that's not always ideal. Sometimes we know something about the building when we want to create this object. Say we know the building name. So I'm going to create another constructor method. It's going to look a lot like the one above it, but this is going to have a single parameter. And we are going to pass in a string called, we'll call it building name. And then inside of this method, we are going to set this local private variable equal to this building name that was passed in when this method was called. And that's real simple here, just name equals building name. So again, building name is coming from the call to the method, whereas name is referring to this local private variable that you declared at the top of your class. And a constructor with two parameters, I'm going to copy and paste this to save some typing. And this I'm going to pass in two parameters, building name and building square feet. Oops, and that is going to be an integer. And we want to set our square feet local private variable equal to this value that we are passing in. Simple. And then finally, say we know the building name and the building square feet and the building cost. I want to code a third constructor method that will account for all three of those variables. Okay, so basically we have three ways that we can create an object. Four ways, I'm sorry. The first way is with our default constructor if we don't know the name, the square foot, or the cost. And we can always define those later. Or say we know just the name but not the square feet or the cost. We can call this constructor method. If we know the name and the square feet, we can call this third method. And if we know all of the above, we can call our final constructor method. And all of these methods share the same name, but they differ with respect to the amount of parameters getting passed in. And those are called overloads. So we could say that the building method has three overloads, because here's the building method, and then each overload is each other way of calling this method. Okay, so that's what a constructor method is. Next, I want to talk about getter methods. Okay, so I mentioned before that these variables up here are declared as private. But say in our building app.cs class, we want to be able to access, say, the square footage or the name or the cost of a building, but these variables are private, so we can't access them directly. But remember, all of our methods have public access. Public access means that if we create an object, we'll be able to call this method from another class. Whereas the only thing that can access these private variables are other things inside of this same class. So a getter gives us read access to these local private variables. And getter methods are very simple to code, more difficult to understand than they are to code. And again, these are methods, and all the methods in our user-defined class should have public access. And methods are going to have a return type but no parameter. So if we want to code a getter for the string name, or for the name of the building, our return type is going to be string, and the name of our method is going to be getName with no parameters passed in. This is a method, so there's no semicolon at the end of the line, but we do want and opening and closing curly brace. And then inside of our method, all we need to do is return name. Remember, name is that local private variable we declared up here. Nice and simple. So when we call this method from an object in another class, we will be able to have read access to that name variable. Let's code getters for square feet and cost. So square feet is an integer. And in here I'm just going to return my square feet, local private variable. And let's code a final getter method. This will return double, and it's going to be for get cost. And in here we're going to return cost. Simple. So that's a double. Our cost is a double. That's why that works. Okay, so all three of these will give us read access to these local private variables. Now mutator methods or setter methods are different because they give us write access, W-R-I-T-E, write access to those local private variables from outside of the class. And think of them as the opposite as these getters, because they're not going to have a return type, but they are going to have parameters. So let's code our first setter method for set name. So when we call this method, we're going to pass in a building name. And what do we want to do with building name? We want to set that equal to our local private variable, to change the value of our local private variable. So that local private variable is called name, and this passed in parameter is building name. That's it. Oh, void. I apologize. Since there's not a return type, we need the keyword void up here. Let's code a second setter method for setting the square feet. That's going to be an integer, and we'll pass in building square feet. That's just what I'm calling it. Nothing special about that. And in here, we are going to set that local private variable square feet equal to this parameter I'm passing in building square feet. And while we're at it, let's finish it off and code a final setter for set cost. That'll be a double building cost, and cost equals building cost. So students often ask, how did I come up with this? Well, really, this can be anything. I could call this anything except this. Don't do this, because then you're going to have something like this, and that's not going to make any sense. We want to specify the difference between the variable that's coming in and the local private variable. Okay, so I could call this XYZ if I wanted to. Cost equals XYZ. That's fine. It doesn't make much sense, but it would work. Just anything besides what you called your local private variable. So I'm just using this word building before it to specify that these are parameters as opposed to the local private variables. Okay, and then I'm going to write one other method to calculate cost per square foot. So these buildings are going to have a square footage and they're going to have a cost, and so a simple math calculation can give me a cost per square foot. And so again, this is a method. All of our methods in our user-defined class we want to give public access to. This is going to have a return type of double, because if I'm calculating cost per square foot, you're going to be looking for a dollar amount, right? Does this building cost $100 per square foot, $200 per square foot of construction? That's a common metric you'd see in real estate. So I'll call this method calculate cost per square foot. Remember, this is a method. Method identifiers should have verbs in them. Calculate, set, get. All right, there's always a verb in our method names. And also notice I don't need to put in parameters. Typically you'd be thinking, wait a second, if you need to calculate cost per square foot, don't you need two things? Don't you need to know the cost? Don't you need to know the square foot? The answer is yes, I do. But since those two variables are already declared inside of this class up here, here's square foot and here's cost, I don't need to pass them in as parameters because they are already knowns in this context. So then my method's going to be really simple. Oops. In here, I am just going to return cost divided by square feet. This cost and this square feet are my local private variables, and that's it. So we have finished coding our user-defined class, and I won't need to return to this to change anything. Everything else I'm going to be doing is in our building app class file, which contains the main method. Notice that there's no main method in our user-defined class, and there should not be. If there was, C# would get confused and say, wait a second, I don't know where to start execution. Only one class should have a main method inside of it. So let's run this, and you can see that all that code that I just wrote did absolutely nothing. So I've just created a blueprint. I haven't created any objects yet. Okay, so in this line of code right here, I am going to create our first object based on that building class. So the first word I want to use is the name of my class. The name of my class is building because it's building.cs. Okay, the name of my class followed by what name I want to, what identifier I want to give my object. This could be anything. I'm going to call it building1. And the names of your objects should be camel case, just like the names of your variables should be camel case. We're going to follow this up by an equal sign and the keyword new. And then here is where we are going to call our method, our constructor method. So we created a constructor method. See, I know that this building is going to be called FCB. I know it's square foot and I know it's price. So I'm going to call the constructor method that has those three parameters in there. So the first parameter, I'm going to pass it as the name of the building. Second parameter is going to be the square footage of the building, 110,000 square feet. And then finally the cost of the building. Say this is an $8 million building. There we go. And finish that off with a semicolon. So again, this is the name of the class. This is the name of my object, what I am going to call my object. Equals new, this is the name of my constructor method. Okay, this constructor method, just to show you where it's located, is right here. This is the method I was calling in the building app class. I'm passing in these three parameters right here. Okay, good. So that was fun. Let's create another building. Start with the name of my class. We'll call this object building2. And equals a new building, and again I know that this building's called SHRM, and this building has 30,000 square feet, and its construction cost was $4 million. Okay, so now I have these two objects based on the same class, and now I can call methods on these objects I created. So down here I want to show the name of building 1 on the console. So I could do this. Building is called token 0. And what do I want to put in token 0? Well, I want to call a getter method from my building class, or excuse me, from my building object. So building1 dot, and then look at all these methods that you probably recognize I created in the other class. And so get name sounds pretty good. Getters don't need any parameters, but they are methods, so they need an opening and a closing parentheses. Okay, so now finally, if we run this, we're going to get something on our console. I should see this building is called FCB. There it is. Show the name of building 2 on the console. Well, let's save some typing. Copy and paste this, but instead of calling getName on our building1 object, I want to call getName on our building2 object. Give that a run, and now we're going to see both building names there. All right, change the name of building 1. So this is called FCB up here, and I'm really thinking, you know, I want to change that to Frankie College of Business, its full name. That'll look a little nicer. And so to do that, to change the value of a local private variable, I need to use one of those setter methods. And that's nice and easy to call. So building 1 dot, and what method do I want to call? How about set name? And setters do need a parameter, and so what do I want to pass it? I want to pass it Frankie College of Business. Okay? And run that. This will stay the same, FCB SHRM, but now if I show the name of building 1 on the console again, I'm going to see my new name. Okay, this is the same line of code. I didn't change anything from up here, but between the time frame when this line of code was run and this line of code was run, we called this set name method, which is changing the name of our building. Let's run that. There we go. Good. So I could change any of these parameters using, or any of these local private variables using my setters. I could, you know, if I realize I made a mistake and SHRM really has 40,000 square feet, I could do building 1 or building 2 dot set square feet and pass in that new value. Easy like that. Okay. So next, I want to show the cost per square foot of each building. I have this cost in square foot for each building, and this was a long line of code, so I already wrote it and just put it in a comment. I'm going to make this appear on 2 lines so you can see it all here. And just because this line of code spans 2 lines doesn't mean it's 2 lines. The semicolon's still here, so it's basically treating all of this as 1 line of code. So we have token 0's cost per square foot is, and then token 1, and I'm showing that as a currency value. And then what am I going to put in for token 0? I'm going to call the getName method of building 1. And then in token 1, I'm going to call the calculate cost per square foot method of building 1. So now when I run that, here it is. Frankie College of Business cost per square foot is $72.73. And say we want this same value, same statement printed for that SHRM building. I can just change this 1 to a 2, okay? Because we are calling the same method but on a different object. And let's run this. And there you can see the discrepancy between the cost per square foot of each of these buildings. So again, classes are blueprints that allow us to create objects. And from these objects is where we're calling these methods, all these getters and these setters, and even custom methods like this calculate cost per square foot method we wrote.